Hello, my name is Firdaus. I'm here because I love to help people in achieving their goal. As planned, today's course is session 1 of 4 sessions, and the title is the basic PLS SEM using SmartPLS. Agenda for today is we will cover or discuss 5 points. Number 1 is what is PLS SEM, when to use PLS SEM. Number 3, minimum sample requirements that need to have a PLS SEM. Number 4, PLS SEM path modeling. Number 5, model creation using SmartPLS. We'll cover specifying the structural model, specifying the measure model, collecting and preparing data, and have SmartPLS software ready for next assessment. So what is PLS SEM? PLS SEM is a second generation technique of multivariate method to test the hypothesis of existing theories and concepts, or we call it also confirmatory, or to develop theory, what we call exploratory. So PLS SEM can be used for both. And focus on the predictive ability of the model. So it's explaining the variance in the dependent variables. When to use PLS SEM? When you have a research goal is predicting target construct, and the structural model is complex. It consists of multiple constructs, and the sample size is small. The data are normally distributed. Measurement scale is nominal. Ordinal and interval can be used 3 of them. And formatively measured construct. Minimum sample requirements as cited by Hare 2017. You can use a rule of thumb provided by Cohen 1992, or alternatively use programs such as G-Power to carry out power analysis specific to model setup, and it can be downloaded from http www.gpower.hsu.te. This is the sample size recommendation PLS SEM for a statistical power of 80%. Provided by Cohen 1992. For instance, when the maximum number of independent variables in the model is 5, using 5, and then you would need 45 observations to achieve a statistical power of 80%. For detecting R-square values of at least 0.25, with a 5% probability error. Now, next we are discussing PLS SEM path modeling. Path models are diagrams used to visually display the hypothesis and variable relationship that are examined. As you can see, there are constructs of variables that are not directly measured and represented in the model as circles like this. And you can see also the indicators, also called items or manifest variables, are directly measured proxy variables that contains rows data represented in the path using rectangles. Relationship between construct as well as between construct and their indicator are shown as arrows. There's also 2 types of latent variable, we call exogenous latent variables and endogenous latent variable. Exogenous latent variable is independent variables, and endogenous latent variable is dependent variables. A PLS SEM model, path model, consists of 2 elements. First, there is a structural model, also called the inner model. It displays the relationship between the construct. And second, there are measurement models, also referred to as the outer model, that display the relationship between the construct and the indicator variables. In this model, there are two types of measurement model. One, the exogenous, and the other one is endogenous measurement model. There are two types of measurement model. One is reflective measurement. Reflective measurement is measure the effect of underlying construct. Therefore, causality is from the construct to the measure. Reflective indicators can be viewed as representative sample of all possible items available within the construct. All indicators are caused by the same construct. Therefore, they should be highly correlated with each other and interchangeable. In contrast, formative measurement models are based on the assumption that causal indicators form the construct. The characteristic of the formative indicator is that they are non-interchangeable. For example, timeliness can be reflected by indicators accommodate last-minute requests, punctuality in meeting deadline, and speed of returning phone calls. That timeliness is manifest by these indicators. That's why it's called reflective measurement. And according to Harlan, indicators must be highly correlated. On the other hand, a formative indicator, for example, the life stress, indicator like jobless, divorce, recent accidents will causing a life stress. So this kind of measurement is called a formative indicators. Model creation using SmartPLS. Specifying the structural models. So the first step we have to specify our structural model. So prepare a diagram that connect construct based on the theory that you have to visually display the hypothesis that will be tested. And establish relationship between them by drawing arrows. For example, reputation, corporate reputation, and another construct is customer loyalty. We want to have a hypothesis between the construct and establish a relationship between them by drawing an arrows. The construct on the left predict the construct on the right side, or in other words, that reputation predict the customer loyalty. Mediation or intervening. Suppose we have two constructs, reputation and customer loyalty. We would like to explain the relationship between two constructs, but we also want to examine another construct that may explain better between reputation and customer loyalty, which is satisfaction. So from reputation, it will get satisfaction, customer satisfaction, and customer satisfaction at the end will give customer loyalty. So customer satisfaction in this context is called mediation or intervening variables. So in this diagram, we have two effects. One is direct effect. It's from reputation variable to customer loyalty. And at the other hand, its satisfaction has a mediating effect, which is indirect effect. It's A times B. Another type of structural modeling is moderation. Suppose we have the same model, customer satisfaction, and we'd like to explain how it affects the customer loyalty. moderation, a third variable, could directly affect the relationship between customer satisfaction and customer loyalty in different way. So it occurs when the moderator changes the strength or even the direction of relationship between two constructs in the model. For example, income has shown to significantly affect the strength of the relationship between customer satisfaction and customer loyalty. In this context, income serves as moderator variables on the satisfaction to loyalty relationship. Specifically, the relationship between satisfaction and loyalty has been shown to be weaker for people with high income than for people with low income. Now we came with the model creation using SmartPLS. First step is specifying the measurement model, the structural model. Now number 2 is specifying the measurement models. There are steps to specifying the measurement model. Number 1, decide the measurement type, whether you want to use reflective or formative indicators, and then select the indicators to measure a particular construct. Number 3, establish relationship between item and construct by drawing arrows. For example, we have here a customer corporate social responsibility, attractiveness, and competence. This is the structural model, and we want to draw the measurement model indicators that reflecting the the company social responsibility. And this measurement model called a reflective measurement, and the other one as the indicator, the arrows from indicators to the construct, is called formative measurement models. Another example of measurement models, if we have competence and like, will causing the customer satisfaction, and customer satisfaction will finally give customer loyalty. And there are indicators that causing or formative indicators on these variables, also on the like variables, and customer satisfaction have one indicators, and this is a reflective measurement model. These indicators represent or manifest the customer loyalty variables. Number 3, and how to create the model using SmartPLS. You have to have data, collecting and preparing data. Collecting data using questionnaire developed from your indicators that you have selected. For example, the competence is competent number 1, so company is top competitor in its market. You have to prepare all these question in your questionnaire. Still in the collecting and preparing data, you have to have a prepared data matrix for the indicators. Once you finish the collection data, make a table like this, the variable name and case number. So put all the numbers into your table according to your indicators. And then examine if there is a missing data, outliers, and data distribution. First, calculate the missing data. If you have less than 5% missing data, Tabaknik and Fidel 2007 suggested to use mean substitution. When the amount of missing data is higher than 15%, observation is removed from the data file as suggested by Hare.